It's Bridget. Hi, Bridget. How are you? Nice to see you. Are you the only one here?
Yep.
All right.
On YouTube.
Like usual, first one here. Okay. All right. Well, so we may have, let's see, somebody else is watching on YouTube. So
nice.
So how's it going? Are you managing?
Yeah, tomorrow's day 28 for me.
Day 28 of quarantine?
Mm-hmm.
Has it really been that long? Wow.
Yeah, I know, right? That was our last in-person lab was 4 weeks ago.
Oh my gosh. And that was just before they canceled all the classes and everything, huh?
Yeah, everything was online after that.
Well, I mean, you're healthy. I'm healthy. I think a lot of people are doing okay. Yeah, that's right. Okay. So are you getting out and exercising and stuff?
Well, not the past few days because it's been raining.
It's been raining, I know. But, well, Mary and I have been walking in the rain too, but you know.
I have to do a lot of workouts at home anyway because I have to keep a daily workout journal for one class, and then I have another workout class that I have to invent workouts for the other students, which is fun.
Nice. Oh, really? Invent workouts. Okay. Have you got some good workouts you've invented?
Yeah, it's a 15 minutes nonstop, 15 different exercises.
Oh, wow. Okay, cool. Oh, I see you're eating, huh? You're eating in the lab? I told you never to eat in the lab. I know. I just had dinner. So it's kind of a funny thing, but so I bet Irvin is on the YouTube. Hold on. Yes, I knew it. Hi, Irvin. Okay.
I wonder if Kat will show up. She probably will.
I'm sure she will. I'm sure we'll get a few people. And I did, Irvin, I did extend your time for you. So when you're ready to take it, you can take it. Okay, so you guys, I mean, we have a couple minutes, so let's see. I have kind of an agenda, but it's probably not going to take 3 hours. Can you imagine? Well, actually, we wouldn't have been able to go outside anyways tonight, but I probably would have showed you a movie or something. There's actually this really cool movie. I couldn't find a version that looks kind of normal. It's built to be projected on a planetarium screen. So it's circular, but the story is so cool. It's called Tales of the Maya Sky. And it's so neat. It's like the Mayan mythology and Mayan, origin story and kind of fun. I don't know, it's fun. But anyway.
Sounds interesting.
Yeah, it's neat. It's neat. I probably would have shown you guys if we were at the planetarium, but so let me know if you can't hear me at some point, and then we'll figure it out. I check my audio, and it looks like my microphone makes little like flickering things, and I know it's working. So I've been doing better, but I'm still learning. And actually, I figured out something. You remember how we couldn't get Stellarium to work?
Yeah.
I think I figured out a trick, and I don't know why I didn't think of it last time, but to take it out of the full screen mode. And when it's not in full screen mode, I think it actually works.
Interesting.
So let's see if I can get that to work. Actually, I meant to use it. Let's see. Let's see if I can get, I don't know. Let's see. How about if I just hit that? Oh, it works. Okay, cool. So actually, you want to test it and see if it works?
Let's do it.
So we have a minute. I meant to test this before. Okay, so you're looking at my Stellarium. This might not work. Can you see it?
No, you haven't shared your screen. Or wait, there it is.
There it is. Okay. And now the question is, can you see it changing? Okay, so I'm turning off the atmosphere. Did you see it change?
It worked.
Yay! It worked. And I'm changing the date. Is it changing?
Yep, we went to a month ahead, 2 months.
Awesome. Great. Okay, cool. So we're in business. That's great, because last time I couldn't, the Stellarium web is okay, but it doesn't have all the bells and whistles that the Stellarium program has. So actually I can now show you some of the neat little features it has. It's actually really fun. And I didn't even know about some of these features, so I had to learn about them today. Anyways, okay, so we got a couple more minutes. Yeah, life is okay, Are you gonna watch Easter service online?
Probably, yeah. There's one tonight at 7:30. It's the Holy Thursday. It's the beginning of the.
Oh, Holy Thursday.
It's the big 3.
Okay, I gotcha. cool.
Yeah, tonight's Thursday, the feast night. So I got my tuxedos and applesauce. It's a good time.
Excellent. Good time. Good times were had by all. Okay, great.
Yeah, we've actually been doing with Justin and Sarah, we've been doing virtual youth groups for the.
Oh, that's wonderful.
It's super
Great.
fun. We have them do scavenger hunts on Zoom. Like we'll
Oh,
be
that's
the first person who can show me their toothbrush and they all go running off. It's really
oh, that's cute. That's like The Price is Right. Did you ever see that?
Yes, I used to love that
The
show.
Price is Right. Yeah, yeah. And they had to like pull things out of their. I think that's right. Let's Make a Deal.
No, that's
Sorry.
that's the show with the Let's Make a Deal one.
Let's Make a Deal. You're right. They had to pull things out of their purse. Yeah, that's funny. You know that? How do you know that?
I watched game shows.
Okay.
Tons of games.
But that's like not even on anymore. So
Isn't it? I don't know. I don't
think
have
so.
cable here.
Okay, let's see. Okay, so that is funny. Let me just go ahead and put a speaker. Okay, I'm gonna pin my. I think I have to pin my video so that it doesn't keep switching. So for the people at home that are trying to watch, I think this is probably going to be easier. Oh, it doesn't work. Oh, and now, yeah, and now it works. Okay. I think it's okay. Okay. So Irvin, you probably will have an easier time if I do it this way. So I am just about ready to start. Are you guys ready to start?
Yes.
Okay, so let's get started. So welcome back. This is the lab, even though we're not going to do, what the heck? Oh, Irvin's connecting.
Oh, Irvin's coming. Oh, do you have to record it on Zoom or are you just doing it on the YouTube?
No, I'm recording it to YouTube, but I don't know why it unpinned me. Pinned video. Okay. I don't know why, but because otherwise, I think what happens is it flips between whoever's speaking or whatever. I don't know why, but I think that's okay. So Irvin, you don't have to connect if you're happy on YouTube, that's fine too. But otherwise, it's nice to see you and maybe hear you. We can hear you. Okay, so I think it's working now. All right, so what I would do if we were in the lab is I would go ahead and get started. Before I do, let's talk a little bit about what? I don't know what to talk about. Let's see, the class, I guess. Is there anything on the class that I'm supposed to be telling you? Oh, I know what I need to talk about. Okay, so let's see. Okay, so let's start off by talking about the class. And actually, first of all, I changed the due date for your sheet 12A. If you already turned it in, that's fine. But if you didn't yet turn it in, the idea was for you to look at the stars, actually, to go look at the stars, not to use an app, right? I know some people use the app, but you kind of missed the point. It was meant, you were meant to look at the stars yourself and try to figure out the magnitude of the stars. On the back page 12B, there was just that one section, and there's a bunch of dots that are showing up. I don't think I have them here. Where I don't have. Oh, I can show you here. Never mind. I can show you. I forgot. I've got a camera right here. Let me just switch to the other camera. And so 12B, the backside here. So people were a little bit confused about what this is asking. So the little line is drawn to this star here, and this line is drawn to this star here. This is a magnitude 2 star, and this is a magnitude 4 star, and down here is the magnitude 3 star. Now, if you recognize it, what's this little cluster of stars called? Anybody recognize it?
That's Pleiades, right?
Of course it is. That's the Pleiades. And so then you can get your bearings, right? You can see this is the Pleiades. So here, this is Perseus, right? There's a little triangle right here. What's that?
Triangulum.
Triangulum. And then over here we have Aries. Okay, there's Aries. And I don't know what that is. But anyways, there's Aries, Triangulum, some random star, and then Perseus. Okay, so the idea was you could draw a little line here or something like that, and then tell me the number, right? What number, what magnitude number was this? Okay.
Yeah, so, I think that's where the confusion came from because it's a little bit different than the page before. Where everything
absolutely, yes, and I agree with you. It's a little confusing, but maybe that makes sense now. Do you understand? That
yeah.
Each dot that you see, you're trying to get the magnitude of. Okay. So that is sheet 12A, and you still have time to do that because it's been cloudy. So we haven't been able to do it. So anyways, you have a little more time. Hey, Daniel, welcome. Nice to see you. All right, so we are, go ahead. Hey, man. Okay, so we're gonna go ahead and switch over to, what am I doing? Oh yeah, I'm gonna go back to the thing right here. I'm gonna talk about your extra credit. People have been asking, what about extra credit, Sean? And I'm like, yep, we got extra credit right here. Actually, I already have 2 stories at least, I think. But if you want to do an extra credit assignment, oh, it won't let me do this. I can actually see if we have some stories right now. Oh, no, I don't have any stories here. You guys haven't given me any yet. But in the other class, I have a few stories already. You get 5 points of extra credit. And what you need to do is tell me the story, mythology story in your own words. And you should use some kind of a reference. If it's a book, that's fine, or a website, that's fine. But please make sure to cite, which means you have to give me a link to where you got your story from. If you copy the story, you don't get credit. You have to write it in your own words, okay? But really, it's up to you, you know, just write it the way you like. Another fun thing.
This is gonna be fun.
Yeah, it is fun. It's meant to be fun. Another thing to remember is that mythology is flexible. And so you read the one story and it gives you a guideline for what you might want to tell, but you can ad lib and throw in details of your own. Just have fun. And actually, that's the way mythology works. It changes over time. So you might read multiple versions of the story, and they'll say to you, you know, there's like 3 different versions of the mythology. Well, there's more than that. There's actually as many as there are tellers of the story. So it's really kind of fun. A few years ago, I shouldn't even say that. Every semester, I get a lot of creative work. So, I mean, you don't have to be amazing. Just write it in your own words. Okay.
Yeah, I've already got a couple good ones.
You already got some ideas? Okay, cool.
Oh yeah.
How about you, Daniel? You got any ideas for mythology? You'll think about it. You got time. You got time. So then back to the website. I don't know what else I can say. Let's see, back to here. Is there anything that you have to do right away? You guys are supposed to upload. I didn't check those yet, but you're supposed to upload your activity. Tonight, I don't even have your quiz ready yet, so I'm going to have that for you by tomorrow. Yeah, let's see, what else? Anything else? I don't know. Oh, the telescope quiz. When is the telescope quiz? Telescope quiz is due by next week. You need to take it by next week, okay? You should look over at any of this stuff. If you missed the lecture, make sure you watch the lecture. There's the PowerPoint for it. Did you guys see the little changes I made? I hope you did, because I realized I never really talked to you about telescopes a little bit. So the changes that I made were, is bigger better? Do you remember? Is bigger better when you're talking about telescopes? Bigger size, bigger mirror or aperture or objective lens, you know, that's good. But magnification is not important, right? We don't need a high magnification to have fun with the telescope. So bigger is better. If you can afford a bigger telescope, buy a bigger diameter telescope, because bigger diameter means more light. Okay, so that was kind of a big thing I was supposed to talk to you about. And hopefully you looked at the slides and saw that. And let's see, what else? I think there was something else, but I can't think of it. Oh, no, can't think of what that was. Anyways, if you looked at the slides, I mentioned the information. You took the quiz, so I'm sure you did fine. Okay, so meanwhile, let's see, let's practice our stars a little bit, our constellations. I don't know if you've been practicing, but now that I know I can use it, I'm going to use Stellarium in a window mode, and I'm going to be able to talk about the stars with you. So let me just get that ready 1 second. Stellarium, okay, and let's see if this works. Okay. And I have this, okay. So I'm going to share my Stellarium window with you. Okay, so here we are, we're looking at Stellarium. And the nice thing is, remember that you can advance time. So you just click over here and you get to your date and time. And we used this last week, so you guys know all about that. I can move forward a couple of hours. I don't even need to go that much further, just, you know, an hour. Oh, I need Arcturus, right? I need to be able to see Arcturus. And then I can even turn on constellation lines. We'll just do that a little bit. And, oh, I don't want the labels. Forget the labels for a second. Let's see if we can do this without the labels, okay? So starting off, actually, I can see the names, darn it. Okay. What is the name of this star or object? It tells you. Sirius, right? Okay. And then jumping over, I can already see Procyon, and I can see Pollux, but what's the star right next to Pollux?
Castor.
Castor, okay. And then higher in the sky, it's already showing up, Capella.
Capella.
Yeah, there's Venus, Aldebaran. Okay, so we got Betelgeuse. What's next to Betelgeuse?
Bellatrix.
Bellatrix. Down here we have
Rigel.
Rigel and
Saiph.
Saiph. And you can check, right? You can check your answer and see if you got it right or not. Actually, there's all this random stuff. I don't know how to get rid of that. Maybe hit
That's a lot of data.
Escape. There's stuff everywhere. Oh gosh. Okay. All right. I can't get rid of it. Okay. In between. Okay. So this constellation. What is the proper name of this constellation?
Gemini.
Gemini. And the common name?
Twins.
The twins, right? Gemini, the twins. And then over here we have a new constellation. One of our new ones. What is the proper name of this constellation?
That's Leo.
That's Leo, the
Lion.
Lion. Now you can
I'm
see
a Leo.
the back. You're a Leo. Awesome.
Yes.
Okay. We are going to do a fun activity, maybe not next week, the week after, where we talk about astrology.
Ooh.
And we're gonna analyze somebody, a volunteer, whoever wants to be a volunteer.
Oh, I'm down.
You're down for that? Okay. So Regulus, we can already see Regulus is the bottom of the backwards question mark. Now this gives you way too much information. You can see the distance, 79 light years. Okay. I don't know how to click off. How do I get rid of this window? I can't get it.
Oh Lord.
How do I get rid of that? How do I just get rid of it? Okay. Anyways, I don't know how to get rid of it. How do I get rid of something?
So much detail.
Oh, there you go. Right click. Okay, cool.
Nice.
Too much information running through my brain. Now, does anybody remember the name of the tail star? Bridget is the only one with her voice on. So.
Thanks for that. It's no, wait.
Yeah. That was
Denebula?
good. Denebula. Very good. Denebula.
Ooh.
Right click turns it off. Cool. Okay, how about this star down below Leo, the lion, down here? Anybody remember the name of this star? Starts with the letter A.
It's
Alphard.
Okay. Alphard, there you go, Alphard.
There you go.
And now, so there's a constellation in between Leo, the lion, and Gemini, the twins. What is the constellation that's in between?
Cancer?
Cancer, the?
Crab.
The crab, okay. And then zooming in, there's something really cool. A cluster, see it? Look at that cluster. Oh, it's so pretty.
It's Cancer.
That's right, the beehive cluster, M44, the beehive cluster. All you have to do is right click and it's gone, okay. How about this big, long constellation right here? Anybody remember the proper name?
That's Hydra.
Hydra, very good. Hydra, the?
Water snake.
Water snake. How about this constellation right here?
Oh,
It looks like a goblet. What is it?
Crater?
Crater, the?
The cup.
The cup. And then the 4 bright stars. There's a couple other little stars too. Corvus, the?
The crow.
The crow. Very good.
Oh.
Corvus, the crow. Okay, here. Take a look at our Big Dipper. See our Big Dipper?
Mm-hmm.
Okay, we got the handle over here and the dipper part here. This is Doobie. I always love Doobie. I love Doobie. Yeah, I know. Doobie. Okay. Remember, you can do 5 steps this way. You get to Polaris. Okay. But we're going to use this handle to do the other thing. We're going to arc over here, and the star is already showing up, but let's do it anyways. Arc to
Arcturus.
Arcturus. And spike to
Spica.
Yeah, unfortunately the names show up. I don't know how else to get rid. I don't know how to get rid. I guess I could turn them off. That's probably what I could do.
Do you turn off the star names? Probably,
I
right?
probably can. Let's see. Turn off labels. That's probably, oh. Okay, so now it's gonna get harder, right? Okay, I just turned off the meteor showers too. Oh my gosh, why did I not see that before? Okay, so should we do it again, or you want to do it again, or you guys okay? Should we do it again? Let's do it again. What is the name of this star or object?
Sirius.
Okay, let's go this way. What is the name of this star or object?
Rigel.
Rigel. What is the name of this star or object?
I'm not like seeing where you're going now.
Can you see it or no?
I can't see it on mine.
Oh, Daniel's lagging a lot.
What happened?
He's lagging.
Oh, it's laggy.
Oh, not for me.
Yeah.
But Daniel's camera is lagging. So I think Daniel, you may be having a bit of slow internet.
Okay. Okay. All right. So
Yeah.
are you able to see me hovering over this star now? It's below Venus.
No.
Ah,
Okay, I see it. I see it.
Yeah,
Yeah.
I can.
okay. And what's the name of that one?
Aldebaran.
Aldebaran. Okay. Jumping over here. What is the name of this star or object?
Capella.
Capella.
Capella. Jumping down. This star right here. One of the brothers.
Castor.
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 Pollux.
Pollux. And this one?
Procyon.
Procyon. Okay. How about here in Orion?
That's,
Betelgeuse.
Betelgeuse here.
Bellatrix.
Bellatrix.
We did Rigel.
Rigel.
And
Saiph.
Theus.
okay.
Theus.
Jumping over to here. What is the name of-
Regulus.
Regulus, right. And at the tail,
Oh, I said it before. It's Denebula.
the nebula.
Denebula.
Okay.
Yeah.
Jumping up to the Big Dipper. Take the handle and you arc to
Arcturus.
Arcturus and
Arcturus.
spike to
Spica.
Spica. Okay, don't forget down here below Leo. I forgot Leo. What's the name of this star here?
Alphard.
Alphard. Very good. Okay,
Alphard.
let's try our, yeah, so you can just click on it and then you can check yourself, right? This is an awesome program to play, to practice with. Okay, and then the constellation, what's the constellation called, this proper name?
Gemini.
The
Twins.
in between Gemini and Leo, what is it?
Cancer.
Cancer, the crab, okay. How about down here? Spica is one of the stars in it.
Wait, okay.
Okay, it's called, this is called Alpha Virgin.
Oh, Virgo.
Virgo.
Oh.
Very good.
Okay.
Virgo, the what?
Maiden.
Yeah, you can turn the labels back on here. You can turn the artwork too.
Ooh.
Kind of a fun little planetarium, huh? You want to turn? We'll turn the artwork on.
The tail on that bear, though.
Oh, I know, right? Isn't that wacky? Okay.
Even
Yeah,
no
raccoon
matter what
tail.
map you,
That's
no
a
matter what
mythology.
map you're on,
Okay.
their dogs
Right.
look like dogs.
Okay, so you arc to what's the star again?
Arcturus.
Arcturus. And what's the name of the constellation? Okay.
Oh.
It starts with the
The
letter
herdsman.
B.
Oh.
Shake your.
It's not the herdsman.
Yes, it is. Buotes the
Oh,
herdsman.
Buotes.
Buotes the herdsman. Okay.
Boaties.
And what's the nickname because of the shape right here? You could go to
Oh,
McConnell's.
the
and get
ice cream cone.
An ice cream cone, right? And then what was this one here? The 4 stars.
Ice cream.
The crater.
Oh.
No, wait, not crater.
crater's here.
Corvus.
Corvus,
The crow.
and then this one right next to it was
That one's crater.
crater,
The cup.
and the big long one is
Hydra.
Hydra, the
Water snake.
water snake. Okay, now looking up high, we have a couple of constellations. So this one is wrapped around the Little Dipper. Let's turn off the art and the lines for a second, just so you can see it. So you see there's the Little Dipper, right? And the Big Dipper, right?
Mm-hmm.
And you can see this line of stars in between, and then it jogs over and then down like this.
Wow.
And that is called, what is that one called?
Is it Draco?
It is Draco the
Dragon.
dragon, okay. And then we have the W shape, remember that?
Oh, it's Cassiopeia.
Cassiopeia, one way or the other. And she is the what?
The queen?
Oh.
She's the
The
queen
queen.
of Ethiopia. And
Ah.
she's actually punished for her vanity or her, the story about her daughter, right?
Ooh.
And so she's
No, I don't
put in
know
that,
this.
what is this? What, I didn't tell you the story. I told you the story.
You told us there was a king and a queen, but I don't think you told us a story.
I
Oh,
didn't.
It's Isn't that the chained goddess's mom?
Who?
Would that be the chained goddess's mother? That's why she's chained.
That's right. That's right.
Oh,
Oh, no, wait. I never told you the
No.
story.
No.
Oh my gosh, are you kidding me? Okay, well, maybe I should tell you the story.
Yeah.
But let's do
Yeah.
our lesson tonight, and then I'll tell you the story. Okay. So so this is Cassiopeia, but actually now I'm like, what the heck? How did I not tell you? Anyway, she's the queen, and the nickname is the chair. She's being punished. If you go from the center star, which is called Navi, Navi, and that was named relatively recently by an astronaut, and you go towards Polaris, the North Star, which is at the end of the handle for the Little Dipper, you pass the tip of this little shape right here. And so what is the proper name of the constellation?
That's the king.
It is the king. His name is Cepheus. Cepheus the
Cepheus.
king. Yeah, Cepheus the king. And his nickname, because of the shape,
The house?
the little house. Yeah, a little house. Like when you were a kid, you might have drawn something like that. Okay, so that's our constellations, and that's kind of a nice, I think it's a really cool tool to use if you want to practice. But let's see, have you guys actually, I know Venus is high in the sky, definitely high in the sky. But tonight's class is actually on, well, it's on Venus too. Actually, a neat thing you can do, I don't know if you guys know this, you click on the object, and then down here, there's a little arrows right here, or you just press the space bar. Never mind, just press space bar, and it makes it go to the center of your view. And then you scroll and you can see the phase. So actually, it's kind of fun to see Venus go through phases, and you can then bring up the time and the day. We can actually see some kind of cool things if you watch it. Day after day, you can see it changing, right?
Oh.
Venus has phases, right? So actually, what phase would you call it right now?
Waxing crescent.
No, this would, I think
Can you see anything right now?
Oh, it'd be the new.
No, that's new.
Now it's new, right? And if I keep going, watch. Oops.
Whoa.
What just happened? What the
we're,
heck is that? What
Where are
happened?
we?
Watch.
we're so close to Venus that all we see is Venus.
Oh no, it's
Oh my God.
No, it was someone's house.
it's the ground. Okay, sorry, that's what happened. Okay. I knew something weird was going on. Okay, if you keep going, watch what happens. See the crescent coming now?
Ooh.
Right? Okay.
So it's
So
a
it was
waxing crescent.
I guess so. It's a little bit confusing. I might call it a waxing crescent because it's going away from the new moon or the new Venus, right?
Yeah.
But you can definitely see that it's well, it's not quite. Do you see a little tiny sliver down here? I see his little sliver.
Yeah.
Huh?
And then right about there, it looks like it's perfectly new. So what does it mean? Like, why would this be new? Where is the sun?
Directly in front of it.
Exactly. So I can't see that, but the sun is over here, right?
Oh.
So I really wouldn't be able to see this Venus. It would be right in front of the sun. It's not lined up perfectly with the sun, but it's definitely in front of the sun. Now I can't tell from this perspective, but there is a new thing that I discovered that I didn't know about before. And it is a way to go to another location, and I'm going to use it a little bit later, but let me just try it right now, see what happens. So I click on the search bar, and I'm going to type it in, solar system. Oh, you can see the words, right? You got to type the whole thing, though, I guess. Solar system observer, right? You guys writing this down? It's so cool, right? And then what I'm going to do is I'm going to go and use that as my location. And so what I need to do is make that my home location. Okay, that's my home location. So the way you get to that, change your home location, is you press Control and G as in gangster, or G as in God, or G as in good. Okay, Alt G, Control G, right? So now I have jumped up to this perspective that is very, very far away. And I'll show you right now how far away. I'm going to find the sun. Okay, there's the sun. And actually, it shows me the distance, how far away. 467.9 AUs. I'm almost 500 AUs from the sun. But I've just moved a big distance from the sun. So I'm going to zoom in. And I want to show you, look at where Venus is, right? You see Venus and Earth are lined up. Now, actually, there's this cool thing. I was going to turn on layer, but now I feel like maybe I should just do it. Let's see if I can put on, how do I put on? I know how to do it. Let's see, come on. Sky, where's the planets? Where are the planets? Hold on. Oh, here we go. Okay, so solar system objects. Show planet orbits. Oh man, show the planets only. Let's just look at the planets. So I'm actually getting a little bit ahead of myself, but you can see,
Whoa.
you see how Earth and Venus are lined up with the sun right now. So wouldn't it make sense that Venus would be a new Venus right now?
Oh, wow.
It makes sense,
Look at
right?
that.
So what's kind of cool is that you can actually, we're watching, you know, from this God point of view, this is kind of cool. We can actually speed up time.
So would that be considered like an eclipse?
It's not an eclipse because it doesn't line up perfectly. It's
Yeah.
more like, actually, you know what? It's more like the idea that we don't get an eclipse every month because it doesn't line up perfectly.
Yeah.
The sun, the moon is just a little bit above or below the line of the ecliptic plane. Remember that idea?
Yeah.
So that's kind of what's going on, that most of the time it doesn't. It's actually called it's not called an eclipse because it'll never really block the sun, but we call it a transit event. And
Okay.
as a matter of fact, you know what, that would be kind of cool. And I'm actually, I have so much time to spend with you guys now that I don't have to waste time doing other meaningless things. Oh my gosh, I miss meeting in the lab.
I know. I do
Kind
too.
of sad. But anyways, there's little Mercury. Look at Mercury. So one of the things we're supposed to go over today is that the planets move at different speeds,
Go, Merc.
right? And the one that's closest to the sun moves the fastest, Mercury.
Yeah.
And Venus is next, and Earth is third, right? And Venus and Mercury are the only planets that we can see have phases, right? They're the only ones that have phases. Everybody else, when we see them, we have to look away from the sun, right? So here's little Mars over here. Mars is going to be away from the sun. Okay, so yeah, well, so this is a little, I'm getting a little ahead of myself, but it's actually kind of fun that we can watch this. So watching the solar system go around like this is called an orrery. And, you know, we're looking. So these are the inner planets. And then we can zoom out and we start to see Jupiter. Look at Jupiter, right? So the inner planets really whip around very quickly. And the outer planets, Jupiter, takes a much longer time. Does anybody know how long Jupiter takes to go once around the sun?
Oh man, it's like
Roughly, yeah. It's so you can actually figure out the answer pretty close to the right answer. If you remember, there was a formula that I know this is Kepler's law. You're not going to remember this, but T squared equals A cubed. And if you talk about the distance between the sun and Jupiter, it's about 5 AUs. Actually, not exactly 5 AUs, but 5.2, I think. About 5.2. Do I know the distance? Oh, I don't know the distance. It's actually showing me the distance from this observer. So that's not quite right. But it's about 5 AUs. The Earth is 1 AU from the sun. Earth is right here. This ring is the Earth. So Jupiter's 5 times as far. So what's 5 times 5 times 5? What's 5 cubed?
125.
Okay, so what number times itself is pretty close to 125?
11.
11, yeah. So that'd be pretty
really?
close. It turns out it is a little bit more than 5. And so it turns out that it actually takes Jupiter closer to 12 years to go once around. But that's a good guess. How about way out here? Look at where's Saturn? I don't see
Oh,
Saturn.
wow.
Saturn is 10 AUs. Whoa. Where's Saturn? There's Saturn. Okay, I can't even see it. There it is. Oh my gosh, let's just pause for a second and check out. Let's zoom in. Oh, you hit space, right? And then you can zoom in. And there's Saturn. Look at the rings. Oh my gosh, so cool. Anyways, all right, we're not doing all that. Okay. So I've gotten this kind of point of view that puts me way above the solar system. And I want to go back home. So I'm going to go over here to location. And I'm going to go back to my home location. How do I do that? Return to default. Okay. Return to default. Okay, that didn't work. Why not? Return to default. Current location. I don't know. Reset. No, that's not right. Oh, it's failing. I don't know what to do. Okay, just stop it and start it again. All right, we'll try it again. Oh, Daniel, you're on your phone, huh?
Yeah, I am.
Okay, cool. That's cool. It works, huh?
That's all I got.
It's all right, man. That's good. I'm glad you're here. All right, so let's see. Let me try that again. Okay, so actually, maybe I should start doing the lesson now. Okay, so we have our workbook, and you're going to want to get out your workbook, and we're going to take a look at page. Let's see. You want to take some notes, actually, but the page that has a lot of the information on it is page 34A. 34A. So go ahead and turn to page 34A. 34A.
All right.
Okay. So you can write notes on here, or if you want to take more detailed notes, then you could put them in the back of your notebook somewhere. But we're gonna talk about these two pictures. And so the top picture is a configuration of a superior planet. So what is a superior planet? Who can tell me what would you guess is a superior planet? What does that mean? Anybody guess?
Is it the ones closer?
What is it?
Is it the closer ones?
Well,
Those are terrestrial.
You see, take a look right here. We got an orbit for Earth. And where is the other orbit? Is it further or closer to the sun?
Oh,
Further.
I see. Further out.
Mars.
So actually, would you please write down a superior planet is a planet that's further from the sun, right? That's it, superior planet. I mean, I'll write it down if you want. What's a superior planet? A superior planet.
Is further than.
Yeah, further
from the sun.
Further from the sun. So actually further from the sun. You could, in fact, you could say superior to the Earth if you wanted to be specific. What if I said, what planet is superior to Saturn? Are there any planets superior to Saturn?
Yeah, Neptune.
Neptune.
Okay, anybody else? So Uranus and Neptune, right?
Yeah.
So you could say superior to, it doesn't have to be the Earth necessarily, right? Okay. But anyways, looking back at that figure, what are the words that you want to know? And these are words that I'm going to be using tonight. So let's start off with the first one, right? The first one that we might see is when the planet is across from the Earth, it's lined up with the Earth and the sun. Actually, there's another word that is just one of my favorite words that I want to teach you. And it's the same idea. When planets align, there's a word for that. And it's a cool word. And so I want to write it down for you. And actually, I wonder if anybody knows how to say this. Write that word down. Have you seen that word before?
I don't think so.
Isn't it a cool word? What a weird word. You guys are about to learn. What is
synergy?
Syzygy, that's right. Syzygy, syzygy,
Syzygy.
syzygy. Okay, a syzygy is an alignment of planets or other objects or other celestial objects, like the moon, right? So when actually, Daniel, your question about eclipse, right? When does an eclipse happen? When there is a syzygy of the Earth, Moon, and Sun, right? An alignment along a line, right? An alignment. So is that a cool word? I like that word. All right, one of my favorite words, and it's totally astronomical. Okay, so what is going on, right? The planet is across from the sun. So actually, I want you to write a word down. So the word is, the word is already given, opposition. A planet is at opposition when it is across from the sun. But I want you to make a note. What time and where will it be in the sky, right? So think about that for a moment. Like the sun is going to help us to define this moment. When is this planet going to be highest in the sky?
Local noon?
Well, the sun is highest in the sky at local noon, but this is across on the other side of the
So
Earth.
it's 12 at night.
Exactly, right. So make a little note to yourself. When a planet is at opposition, it crosses the meridian at local midnight, right? So it's like, it's going to be as close as, and by the way, if you take a look right here, does it ever get any closer to the Earth than this, right?
No.
And the answer is this is when it's closest to the Earth. So in fact, when you're using a telescope, guess what? You're going to get the best view of a planet when you're at this opposition, right? So the best view is when the planet is closest, which happens to be when it's crossing the local meridian at midnight. Does that make sense? Okay. All right.
Yeah.
So I didn't hear you, but anyways, okay. Now, which one's going faster, the Earth or the planet?
The Earth.
The Earth goes much faster, right? Much faster. It only takes the Earth 1 year. If this were Mars, it would take about
1.5.
It's 1.5 AU, but actually it takes
Okay.
about almost 2 years, not quite 2 years, to go once around the sun. So a Martian year is like 680 days or something like, I forgot the exact number. You can go look it up if you want. But the idea is it's not quite 700, but it's, getting up there. It's close to 700 days, almost 2 years. So if you live on Mars, every Martian year is 2 Earth years, right? Roughly. So anyways, yeah, actually, that's kind of an interesting thing to think about. In fact, maybe that would be the one to study. I'm trying to figure out what I can have you guys do at home that's kind of like a lab activity. And I'm actually, now that you said that, I'm like, that actually would be one of the coolest things to do. Looking at Mars would be really super neat. Okay, maybe we'll talk about how to do that, okay? Anyways, so opposition, it's across from. And then if you look, the Earth is going to move faster than the planet. It means this other planet's going to fall behind, okay? So it turns out in order, which one happens first? And the answer is the Earth is going to be approaching the planet. The planet will be here first, and then it will be at opposition, and then it will be here, right? It's going to fall behind the Earth because the Earth is orbiting faster. It's not super critical, but let's take a look at what this means, right? Where is this planet compared to the sun? Where is it? So what's the angle between the sun and the planet? These are called quadrature. What's the angle? Can you see it?
Is it 90 degrees?
It's 90 degrees,
Yeah.
right? So
Yeah.
what does this mean, right? Think about what this means. If you see the sun at the high point, these things are going to be, so this is where the planet will be first, right? It'll be over here. If I'm standing, actually, I feel like maybe I'm going to go ahead and I've never done this with you guys are making me be a little more inventive, which just makes me very happy because I'm doing things that I've never done before. Thank you so much. Okay. But we're going to go ahead and draw a big picture. This is the Earth, right? Earth. And we're going to have the sun over here. We don't know exactly, but it's over here somewhere, right? The sun. Okay, this way you would put in the back of your book for me, okay? And we have a person standing right here underneath the sun, okay? And which way does the Earth rotate, by the way, in this picture? Assuming I'm looking down at the North Pole, right here. then the Earth-
Counterclockwise.
Yes, that's right. It rotates like that. That means it goes this way around the sun as well, right? Okay. And then off in this direction is going to be the other planet, right? This other planet. Oh, you can't see that. Okay. Here's the other planet. Can you guys see the whole diagram? Okay. So what I want to think about is what is going on. The planet is rotating like this. The sun is going to be going over this direction. And where will this object be? Well, it's 90 degrees away from the sun at noon. Where is it? It's on the horizon. It is what horizon? Well, since the Earth is rotating this way, this is going to be my western horizon over here. Can you read that W? That's my western horizon. So the idea is when it's at this quadrature, where is the object? It is on the horizon when the sun is at noon, right? Which means it's going to go away. We're not going to be able to see it. Okay? Am I doing this right? Feels a little bit off, but oh no, that's good. That's good. Right. Okay. And then the Earth keeps going, and then it's going to be as I go further, right? We're going to reach this point right here, where it's now at opposition. Right? Here's our opposition. Right?
Okay.
And so this one, now the object is going to be directly overhead at midnight. What time did it rise?
12 a.m. Right?
No, 6 hours before it
6
gets to the
p.m.?
highest point, right?
6. Okay.
About 6 p.m., right? So if it's highest overhead at midnight, then it must have risen at about 6 p.m. This is kind of like a full moon, right? Like the full moon. Same idea, same concept as a full moon. And then when we go a little bit further, the Earth is going to be over here now, and we're going to get another quadrature, which I don't have room for. So I'm just going to go back to my diagram. What happens when the planet is off in this direction, right? 90 degrees away from the sun. Now it's actually going to be on the eastern horizon when the sun is at noon. So actually it's kind of an, just helps you see, I don't know if you can understand that these will be visible at different times of the day or night, okay? And that's actually a little bit more than I've ever done. And now I see why, because it's very confusing. Okay, so don't worry about it too much. All right, so that concept is called quadrature. And then we have opposition when it's across from the sun. And then we have this new term, the last term, is when the planet goes behind the sun. We call that a conjunction. Okay, so that's a word that you need to know, conjunction. When a superior planet is lined up with the sun, it is called a conjunction. We can't see it at that point. It is not visible at all. Okay, any other place you can see it at some time of the day or night. But when it's lined up with the sun, you cannot see it at all, right? Whenever it's close to the sun, it's basically invisible, okay? So it disappears for a little while when it's too close to the sun. And the reason is we just we can't look at the sun and see a planet behind it. It's not possible. Okay, so that's a superior planet. And we already talked about superior planets. So there aren't that many. Which planets are superior to the Earth? Can we list all the planets superior to the Earth?
Mars, Venus, Jupiter,
No, not Venus.
Saturn, Uranus, Venus,
Yes.
and
Okay. No, not Venus. Not Venus.
why not?
Venus is on the inside.
Venus is closer
Okay.
to the sun.
Yeah. Whoops.
So yeah, Mars, Jupiter, Saturn, Uranus, Neptune. Okay. All right. Now let's jump to the bottom figure, and we have inferior planets. Okay, so what does an inferior planet mean? As you can see from the drawing,
Closer to the sun.
it's closer to the sun. It doesn't mean less cool, right? It's just, it's closer to the sun. Can you guys read this, or is it hard to read? You have your book in front of you.
It's kind of hard to read, but we have our books too.
You have your own book. Okay, good, good, good. All right, now, so what are the inferior planets to the Earth?
Mercury and Venus are the only
That's
ones.
it. There's only two, right? There's only two. But you'll notice that there's something kind of special. They can be closer to the sun. As we see them go around the sun, guess what? These two planets will show phases, just like the moon has phases. And it's, again, not something that I will talk about it too much, but it's kind of neat to see that. Actually, I just thought of a way that we could check our work. Oh yeah, let's do that. That's good, great. I just thought of something else we're gonna do. Okay, so let's take a look right here. We got an inferior planet, and you'll take a look. Let's start with the conjunction. Oh, wait a second, there's actually two conjunctions. And so the name, when the Earth, planet, sun is lined up like this, it's called an inferior conjunction. And when it's on the other side of the sun, it's called a superior conjunction. So lining up with the sun is still a conjunction, but there's two different ways to line up with the sun now. And so we have these different names, okay? So I would anticipate that if I show you a picture and I ask you to identify which is which on the quiz, which will be ready tomorrow, that this would be like one of the things that you'd be able to identify. Okay. All right, so back to my hand-drawn pictures, because, all right. So I'm gonna draw a picture kind of like what we did on page like 6A, way back when. We had this local meridian line with the altitude. Does that look straight to you? No. Oh my
No.
God. That is not straight. That is such a fail. Oh my God, I'm embarrassed. Okay, I'm hand drawing it though, so is that better?
Yes.
There, now it's better. All right, I don't even need numbers, but remember that there's the east over here, there's south right here, there's west over here. You guys remember this drawing?
Yes.
And if we watch the sun, you know, at different times of the year, it takes different paths. But on what day it actually rises exactly in the east? What day?
Equinox.
Equinox, right, equinox. So we'll draw an equinox, right? We can draw the equinox, okay. So here's one of the equinoxes. It doesn't matter which one, because they're the same path, right? And it reaches a maximum angle in Santa Barbara of 56 degrees, which we don't need that. That's okay. I just wanted to show you. All right. So you can picture the sun rising in the east and setting in the west. It makes an arc like that, okay? Now, it turns out that this path that the sun is following through the sky is not exactly the same. Never mind, that's the wrong thing. What do I want to say? It's not what I want to say. Remember that the sun actually goes higher and lower in the sky at different times of the year, right? Sometimes it's low, sometimes it's high, right? So the different altitudes of the sun occur because of that tilt of the Earth. And if we watch the sun, actually, we see it moving along a path like this through the constellations, right? The path of the sun through the stars looks something like this. And this is called the ecliptic. Okay. So what time of the year is it higher in the sky? The highest point? Going to be 621, right? And then, you know, if I did something like this, right? When is it lowest in the sky?
It's 1221.
1221, right? And when does it cross the meridian, right? Well, 321 and 921. Okay. Or when does it cross the what is this? This is the celestial equator. Actually, this is kind of a cool thing for you to understand. So the sun takes a path through the sky that's called the ecliptic. And another name for the ecliptic, I don't know if you remember, is if you imagine a sheet of paper and the sun in the middle, right? The sun in the middle. Then the planets are orbiting in the same sheet of paper, right? And we call this the ecliptic plane. Does that sound familiar to you guys?
Yeah.
All the planets orbit in that plane. So whenever we see a planet, and actually tonight's planet is the planet Mercury, okay? And so if I count here, 1, 2, 3, the Earth is here. Mercury is going to be the innermost. Oh, that's the sun. Sorry. Okay. 1, 2, 3. Okay. So Mercury will be inside and Earth will be on the third ring. This is supposed to be the sun. Sorry about that. Okay. So Mercury will be the innermost, Venus, Earth, right? Whenever we look for Mercury and Venus, they're always going to be kind of close to the sun, right? So if the sun is somewhere on this path, wherever it happens to be, right? When we look near it, it's always going to be that Mercury and Venus are nearby, right? They're always going to be kind of close to it. And they're always going to be in the plane, which means they're always going to be near this ecliptic path. They're always going to be close to it. So if you're watching the sun, suppose I'm looking up here and here's the sun, right? What time is it?
It's local noon.
It's local noon. And I look and I see, you know, Venus or Mercury are over here, right? Venus, Mercury. Actually, it'll be hard to see this very often, but we'll see some different ideas. Then when I look at this, which direction are they compared to the sun? Are they towards the east or towards the west?
Toward the east.
But towards the east. So when we see them towards the east, we call it east elongation. The east elongation. And when they're over here, right, same idea, then what do we call it?
West.
That's called west elongation. So let's see if we can understand this. Look at this picture with me, right? So you can see there's some words. What is the word here? Greatest
Eastern elongation.
Eastern elongation, and over here, greatest western elongation. But why, right? Why is that east and why is that west? Well, I'm going to draw a little tiny person right here on the Earth, looking up at the sun, right? And you have to kind of use your brain and pretend that you are, you know, turn it sideways if you want, like this, right? So here you are looking up at the sun. Why would this be called eastern elongation? Well, because it's to the east of the sun, right?
Yeah.
Where is this? To the west of the sun, just like my drawing, right? My arc right here. Okay,
Yeah.
does that make sense why those are east or west?
Yeah.
Okay,
Yeah.
good. All right, so back to the story. Would you be able to see these very well during the daytime?
No.
Not at
Nope.
all, right? They disappear during the daytime. So when would you see the planets if they were over here? What time of the day or night would you see them? So where are they? Are they in front of the?
Like sunset?
Well, I'm actually asking you to think for a second here. Are they in front of the sun or behind the sun?
They're in front, right there.
Front.
You would say in front because the sun goes in this direction.
Yeah.
So
Yeah.
do they rise before the sun or after the sun?
Before.
They rise before the sun. That's the clue. When do you see them?
Between midnight and sunrise.
Sometime, right? Just before the sun comes up, basically. They're always
Okay.
pretty close to the sun. So if you are a person who's not taking astronomy class and you look up and you see these bright things, you say, oh, look, it's a what kind of star?
Morning.
A morning star, right? When it has a western elongation, when it's to the west of the sun, we would see it just before the sun comes up, and we call it a morning star. And if it's over here, what's the difference?
Evening star.
Now the sun sets first and they set after, so now they're going to be called the evening star. Okay, so both, and we did talk about this before, but I didn't actually talk explicitly about how they're positioned, but this is in fact what's going on. Okay, so we got these morning stars, we got evening stars. Do you know how long it takes the Earth to go once around the sun?
365 days.
Exactly. And how did we know that, by the way? How do we know that? Did you ever wonder? You don't know. Okay. So actually, why don't we do that? Why don't we pretend that we're ancient and we're ancient people and we have the tools that we have, which are basically nothing. We have our eyes, right? And using our eyes. Oh, and what about the stars, right? We have the stars. Let's look at the stars together. Okay. And so I want to tell you what ancient people did. What they did is they watched the sun, right? Oh, that's not the sun. What the heck is that? That is something else. Okay. Let's make the sun come up. So I'm going to change the time and date. Can you guys see the whole window or just the piece? Can you see it?
You see the whole window.
Okay. Okay, cool. Okay, so the sun. So it's a little bit too bright for me right now. I'm going to turn off the atmosphere. And I want to actually take a look for a second. I want to look at the constellations. And I want you to understand something, right? So I'll put on the artwork. So even if you were an ancient person, right? When the sun went down, oops, when the sun went down, there we go. When the sun went down, goodbye, sun. I don't know. I can't see it so well. You would look and you would say, what constellation is the sun in? So pretend that the sun has gone down. I don't want to, I guess I have to turn off the ground too, but then you can't tell where the ground and the sky are. So I don't know. It's confusing. All right. So you see the sun goes, just pretend that the sun has gone down and you can see this branch of what constellation?
2 fishes.
The 2
Pisces.
fishes. You see Pisces. So the sun is clearly in Pisces, right? And
Yeah.
now, okay, so the sun is in Pisces. What about in a month, right? In a month, is it going to be in Pisces anymore?
No, it's like the 12 signs of our zodiac.
Right. So if I advance forward, I'll leave the sun in the center of my picture here and advance forward. I'm waiting for the sun to go back into, what the heck?
Whoa.
I went too late. Okay. I went to Libra, okay, Scorpius, Sagittarius, Capricornus, Aquarius. Okay, it's back, right? And how much time has passed?
12 months.
Exactly a year. If you watched very carefully, that's exactly how long it would take for the sun to come back to the same position again. Okay, so it takes 1 year. So every year, look at this, every year, the sun is going to be in that constellation. So we know a year has passed because the sun comes back to the same position in the stars, right? All right, so we understand that ancient people knew how long it took the Earth to go once around the sun. It takes a year, okay? We need that information. We need to know a year, which we already know. But what we're going to do next is study the movement of Mercury. So Mercury is our choice tonight. And there it is, Mercury. So it actually turns out to be below the ground right now. Oops, wrong thing. Never mind. It's not. It's not below the ground at all. Okay, so what I want you to do is we're doing something a little bit, we've turned off the atmosphere. This is daytime, right? Turned off the atmosphere. It's daytime. We shouldn't be able to see it, but it's kind of important that we do this anyways. I want to do this. I want to center Mercury now. Okay, so I've just pressed the space bar, or I can click this little button here. By the way, it does the same thing. And I want to make time advance. Oh, I want that. Never mind. I want that. I want to make time advance. And I want to watch Mercury right now. Okay, so I want to just watch what it does. Just watch it for a little while. So I could actually, you know what? I could just speed time up. Speed time up. I want to watch Mercury. Why is it going down? Oh, because it's not visible. What What the heck?
It's focusing on Mercury going around the Earth, like in a
Yeah, I know. So I want to go even faster than that. Oh, this is confusing. Oh, this is
Whoa.
super, super cool. All right, cool. Never mind. Let's stick on the sun then. Okay. So what I want
would
to do,
would that
Huh?
be considered like a retrograde movement?
not yet. Actually, we didn't see
Okay.
that. We've only gone a week. We haven't gone long enough, far enough.
Okay.
So actually, this is the problem. The Earth tilt is the problem. Yeah, that's confusing. Okay, so I guess I can't do this. I wanted to do this, but it's not really working. I wanted to do this. I really wanted to, but what's confusing is that because the sun is actually in different positions relative to the Earth, the whole screen is tilting. I don't want to do that, so I'm just going to skip day by day. So watch day by day. Oops.
wow.
Let's go back to centering. Okay, now watch day by day. Look what's happening. It's getting closer to the sun. Now, would you say it's to the east or to the west of the sun right now?
It's to the east.
West.
It's to the west, right? It's to the
Yeah.
west. Okay, to the west. So is it a morning star or an evening star?
It's a morning star.
It is a morning star, okay? And now let's keep going. And now what do you call this? Lined up with the sun.
It's
Oh,
it's an
opposition.
opposition.
Not with the
No, wait.
inferior planet. Look back at the diagram again.
oh, it's
Conjunction.
inferior conjunction.
Well, I can't tell, can I? I just know it's a conjunction.
Okay.
So what I'm going to do is I'm going to zoom in and see if I can see. Oh, can you see how I'm seeing the sun first? What kind of a conjunction is it?
Oh, it's superior.
It's a superior conjunction. Does everybody get that?
Mhm.
Okay, so yeah, whatever. I can't see it. Okay, keep going. Oh, it appeared again. Okay. So if I look now, what phase do you think it'll be?
It's evening star.
Oh, sorry, but what phase?
Oh, it'd probably be
New, right?
yeah, new.
Does it look new to you or does it look full to you?
Well,
Okay,
that looks kind of full.
It is pretty full, right? So when it's on the far side of the sun, we can see the whole face lit up. It's full.
Okay.
Does that make sense? Okay.
That makes
All right.
sense.
Okay, keep going. And watch it a little bit day by day, right? What's happening? Is it becoming more or less full?
Less.
Less full. Okay, so I'm going to back up. So anyways, you can see phases with Mercury. Oh, I'm lined up with the sun again, right? I'm going to zoom out so I can watch it again. I really wanted to see that. So when you're lined up with the sun, it's a conjunction. When it's a full Mercury lined up with the sun, it's on the far side. It's called a superior conjunction. Okay. So now, what would you say, to the east or to the west of the sun? That was what you wanted to tell me before.
Now it's the east.
Well,
The
just say east or west. It's to the east, right? So
Yeah,
morning
east.
star or evening star? Which one?
Evening.
Evening. Very good. Now you see it's getting further away, right? Now I could have turned on something. I think that's what I want to turn on. There's a marking called the ecliptic. The ecliptic. And you see how this is the ecliptic, right? The path that the sun follows. Mercury and Venus and all of the planets are always going to be close to this path, right? They're always going to be close. And so as I go, what do you notice? Getting closer or further?
Further.
Further. So it's getting more elongated, we say, right? And there will come a time when it is as far away as it can get. And that's called the greatest elongation. Okay, that's the term that we use. So I don't know when that is. It's actually, we're going to study that a little bit later. I don't know. Can you tell? Is it getting further?
Yeah.
Seems like it.
Yeah.
Actually need to zoom out again, huh? Now, getting closer or further? Oh, it's getting closer again, right?
Yeah.
Okay, so now what do you see? Is fading, right? You see how it's fading?
Yeah.
Why is it fading? So if we
It's
zoom
going
in,
to a
what
new.
phase? It's new again, right? It's new.
Yeah.
If I go
So
back
it's,
a day, oh, now I see that tiny little crescent.
So
If
that
I
would
go-
be an inferior conjunction.
Excellent, excellent, excellent. Okay. All right, so we just watched Mercury, but we're going to go ahead and do something a little more precise now. And so we're going to do a little activity, a timing activity. And I have some ideas for something that maybe I've never asked another class to do that you guys might end up doing. If you could turn to page 33A for me. Turn to page 33A. And let's take a look at page 33A. So it says here, determining an inferior planet's sidereal period. What does that mean? What does sidereal period mean?
Oh.
Anybody remember that word, sidereal? Okay, how about this?
No.
Do you remember sidereal and synodic? Remember the two words, synodic? When we did our solar observation, we asked the question, are we observing the synodic period or the sidereal period? Okay, so you might want to write down the words and I'll write them down for you, okay? So what is synodic and sidereal? Let's write down, what does sidereal mean, okay? Sidereal, sidereal, means relative to the stars, okay? Synodic means relative to the sun. That's what it means. But we can also think of it as seen from Earth. Okay, so when we measure the period, are we measuring the sidereal period or the synodic period?
Oh, we're measuring how we see it from Earth, right?
Yeah, so that's got to be what?
Synodic.
It's got to be the synodic period. Okay, so we're going to be measuring the synodic period. Let's go ahead and write down, let's do Mercury. Okay, we're going to do Mercury, right? But it already says Mercury, but it doesn't say that. It just says, it doesn't say, actually. Is Mercury an inferior or superior planet?
It's
Inferior.
Inferior, right? It's an inferior planet. So what we want to do is we want to watch Mercury go through a single cycle, and we want to measure the amount of time it takes, right? And that will be called the synodic period from our point of view on Earth. Now, I found out that the easiest thing to do is, instead of watching Mercury move, it's actually a lot easier to zoom in and look at the phase, and it's actually, we can get a more precise value this way. So you see how it's a crescent right now? I'm going to back it up until it's a new moon. So what is this called one more time when you have a new moon? A new Mercury?
That's the what's it for? It's the
Inferior conjunction.
Yeah.
Mm-hmm. Okay, so everybody write down the starting date. Write down 6/29/2020. Okay, 6/29/2020. And what we're going to do is we're going to step forward until we see it come back to a new Mercury again. Okay, so I have a Mercury. I'm going to step forward and I see, look at that beautiful crescent. Oh, isn't that beautiful? Look at that crescent. Oh. And actually, I already went past like a first quarter, right? Looks like a first quarter right there. Keep going. Now it's gibbous, right? And now it's nearly full. I would say it's just about full. Looks like full to me. And it's full. And now you should start to see that it is actually getting less full. Okay, it's now a waning gibbous. And it's now a third quarter. And now it's a waning crescent. And
New.
pretty much, right? Would you say it's pretty good?
Yeah.
Okay, so write down the date, 10/25. Whoa. Now, it's not perfect, but are we friends or are we enemies? Which one?
Friends.
Let's be friends. Okay. So let's go ahead and say it's only 4 days off. Let's just say it took 4 months. Okay. So can you please write down for your synodic period? Let's put down about 4 months. So 6/29 to 10/25. It's just 4 days off. Not a big difference.
Nice.
Okay, are you guys okay with that?
Yeah.
Yeah.
Now, it's not exact either, but about how many days are in a month?
30,
30,
30 days in a month. So what would 4 months be? How many days?
120.
20.
120. Okay. So you could put down 4 months, which is about 120 days. Okay, now I get to lecture for a little bit, and I want to draw a little picture for you. So we have our synodic period, 120 days. Okay, so this is kind of a fun thing to understand. Which one's faster, Mercury or the Earth?
Mercury.
Mercury, of course, because it's closer to the sun. So we want to draw a little picture right here, and I'm going to draw a circle for Mercury, and then another circle which is further away for the Earth. And I want them to be lined up with each other because they were, right? If Earth is here, Mercury would be right here. That's an inferior conjunction, right? This is what was happening on, it was a 629, right? This was 629. So Mercury goes around the sun. Does the Earth stand still?
No.
Of course.
Of course not, right? So as Mercury goes, right, Mercury takes off, and actually there's a little race here, but we know Mercury is faster. So Mercury takes off, right? And Earth takes off, but Mercury goes super fast and actually catches the Earth over here somewhere. Now, how do I know that? Because it was 120 days. Now, I don't know if you remember, how many degrees are there in a full circle?
360.
And how
Yeah.
long does it take the Earth to make one orbit around the sun?
365 days.
So how far does the Earth move in one day?
It's about 1 degree.
About 1 degree. So how many
Yeah.
degrees in 120 days?
120 degrees.
About 120 degrees. So 90 is 1/4. 120 is like this. So I want you to draw a picture like this where you have a 120-degree angle and another 120-degree angle and a third 120-degree angle. 120 plus 120 plus 120 equals
360.
360. And so what happened is Mercury took off, left the Earth behind, and then Mercury caught the Earth again when they went back and when they were over here in this configuration. And this is what happened on 10/25, right? 120 days, roughly 120 days later. Okay, does that make sense? So the Earth has moved 120 degrees. How far did Mercury go?
Oh, good question.
It went all the way around. How many degrees in a full circle?
360.
And then it went extra how much?
Oh, another 120.
Another 120. So Mercury, or let's write that down. Earth went 120 degrees, but Mercury went 360 plus 120. Mental math, what's that?
480.
480 degrees. Okay, so the question asks, how many degrees did Mercury move? And now you know, it went one full orbit, 360, plus that extra 120 degrees, which is based on the fact that it took 120 days for Mercury to catch the Earth again, right? To be lined up again. And so we got 480 degrees. So how many degrees did Mercury move per day? Well, so you're going to take the number of degrees, 480 degrees, divided by the number of days, 120 days. And so what do you get? 480 divided by 120. Can anybody do that?
40.
Not 40.
No.
4.
4
just
degrees every 1 day. So the question says, how many degrees per day did Mercury move? And that's your answer, 4 degrees per day. Sound good?
Mm-hmm.
Okay, the last question. How many days should it take Mercury to do one orbit? Because that 360 degrees is a full orbit. How many days does it take at 4 degrees per day? How many days is going to give me 360 degrees? Mental math. 4 times what equals 360?
It's gonna be 90.
It is 90 days. Okay. And so this is what we predict is the sidereal period for Mercury. Okay, 90 days. Now that's not correct. I'm sorry, it's not correct, but it's really close. Does anybody know the actual orbital period? The actual period? You're gonna love this.
80.
It's 88 days. So you can
Yeah.
see, does that make sense to you? Remember that we used just a little bit too long. It was 4 days too long. And in fact, if you worked it out, we would have gotten, you know, something pretty close to about 88 days. So anyways, it works pretty well, gives you an idea. So we just determined the sidereal period for Mercury. Okay? Sound good?
Mhm.
Sounds great.
Okay. All right, now we're going to do a second activity. And that is actually, unfortunately, I don't know how to do this because does anybody have a compass at home? I'm sorry, a protractor at home? Protractor?
No.
See, if we're in the
No.
lab, I have a whole set of protractors for you, but we're not in the lab, so no problem. We're going to do our best. I'm going to draw a picture for you and then ask you this question. So here's our sun. Sun's in the middle. And I'm going to do a smaller orbit and a bigger orbit. Sorry about that. Not very pretty. Doesn't have to be pretty. Don't worry. Okay. So here's the Earth. And I want you to, we'll leave the Earth there. We're not going to move it. But Mercury is going to move around and we're going to try to ask this question. If Mercury is over here, right, what would that be called? Eastern or Western elongation? So again, you want to imagine you're looking up at the sun right here. Which way is Mercury from the sun? Is it towards to the left or to the right?
Left.
To the left. And now if you were looking up at the sun, would that be to the east or to the west?
East.
So this is over here, right? Anything over here is eastern elongation. Check your diagram and make sure you see that, right? So if I'm looking at Mercury, I'm actually going to be asking the question, how far away is Mercury from the sun? And the way that ancient people could have done this, by the way, this is actually something kind of cool, is instead of, actually Mercury was very hard to do because Mercury is always really close to the sun. But the idea is that when you want to find elongation, it's all about how far away Mercury is from the sun, which means an angle. So it's an angle between the sun and Mercury, this angle right here. This is the elongation angle. Okay, that's our elongation. That's the angle right there. I actually just realized I had something I could show you. Let me see. You know what? I'm going to, hold on one second. I got something. I've been waiting for you all day to see this. And I totally forgot about it. Now let me go back to my, I actually found this cool app and I'll put the link for you. It needs Flash, unfortunately, but this is yeah, UNL, University of Nebraska at Lincoln, astronomy education. And so there's this term called elongation, but it's just, all it is how far away from the sun is the planet. So you see right here, if this is the sun that's setting, right, it's got to be the setting sun, right? Well, I don't know that, but I'm guessing it's the setting sun because of I'm a northern hemisphere person. But if this is the setting sun, then what kind of elongation would it be right now in this picture?
Well, it'd be Eastern.
That's Eastern, right? And so is it a morning star or evening star?
Evening.
An evening star. So if you just measured the time it took this star to finally set after the sun, the longer it takes to set, the bigger the angle will be between them, right? So if it's very close to the sun, it sets right after the sun. But the bigger this angle is, the longer it will take that evening star to set. And so if you were a primitive person just watching, you know, these things, you didn't know what they were, you could still measure the amount of time after the sunset that it finally set. And you might think that was kind of interesting. And you could even find when is it greatest, right? And then it would be getting longer, 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 and then it's going to get shorter, shorter, shorter. So there's a day when it's longer than every other time. And so we already talked about this, the planets that are closer, inferior planets, they show phases. The superior planets do not. They always look pretty full. They can be gibbous, but actually otherwise look pretty full. And now here is the idea. So blue, that's us, right? Here's an inferior planet. And it showed you the conjunction. What kind of elongation? It is Western elongation. If you pause it, can I pause it? It doesn't let me pause. Okay, no pausing. But it's Western, and you'll notice that it's getting closer now. See, the angle between the sun and the planet are getting smaller. And then it is superior conjunction. Okay, and now it's to the east of the sun. It's an Eastern elongation. Okay, it's getting bigger, 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 and so on, right? So that's the inferior planet. So a lot of times people imagine, like, when would the planet be furthest away from the sun as far as the angle is concerned? And I want to draw that picture for you because a lot of people are confused by that. Sometimes people think that, hey, if this is a 90-degree angle, then that means that the planet will be furthest away from the sun. But there's a reason why that doesn't quite work. And I do have a ruler to draw for you. So I want to take a ruler and draw it between the Earth and the planet. And I want to show you that there's a lot of places where the planet could be, where it would actually be further away from the sun. And so this point when the planet is furthest away from the sun is kind of special. It's called the greatest elongation. And the way you figure it out, it turns out is really simple. You draw a line between the Earth and the orbit of the planet that just touches the edge of the orbit like this. Does anybody remember the name of a line that touches a circle in one spot? Called a tangent line.
Tangent. Okay.
Okay, so it's a tangent line. And when Mercury is at this position, it's actually going to be furthest away from the Earth, from the sun. That'll be the biggest angle away from the sun. So when Mercury touches the circle and it's on this tangent line right here, that's as far away as it can get. There's no other place that's as far away from the sun as this one. And so this is the point of greatest, which one, Eastern or Western? Greatest Eastern elongation. We could put G, greatest Eastern elongation. Now, if you draw a tangent line, this is something that, again, I didn't expect anybody to know. But if you draw a tangent line and then you draw a line from the center of the circle to that point, this is the radius right here, right? The distance is supposed to be the same all the way around. Do you have any idea what is the angle between a tangent line and a radius? Does anybody want to guess? The answer is a 90-degree angle.
Oh.
They're right angles to each other. So this is a really special thing. It turns out when you are at the greatest Eastern elongation, you are going to make a right angle with this tangent line and a line connecting the sun and the planet. And so what do you call a triangle that has a right angle in it? Does anybody remember what they're called?
Equilateral.
Not equilateral. That means it has the same angles, right?
Isosceles.
It's called a right triangle.
Ah.
Are you joking with me, or you?
Yeah, a little bit.
Okay, sorry. Okay, I don't remember. I don't know. So we labeled as A, B, C. Okay. And what if I draw a bigger version that has exactly the same angles, right? It's a right triangle, but the angles are the same. Do you remember what they're called? If they're both right triangles, but they have the same set of angles, they're called similar triangles. Does that sound familiar?
A little bit, yeah.
Okay, and you could put capital A, capital B, capital C. So you got a little triangle, you got a big triangle. But the cool thing is that when they're similar, they're related to each other actually, mathematically. And it turns out that you can do a kind of a cool trick. If you take big A and divide by little a, it will equal big B over little b, or big C over little c. The ratio of any two sides will give you the same quantity. You could take big A over big B, and that will be little a over little b. All right. I mean, anything you want, any ratio you want is going to be true. It's kind of a cool trick, right? And so the reason I'm telling you that is that the distances between the planets is big, right? Actually, imagine I tried to, I mean, think about it for a second, right? Let's say that I'm drawing a picture for you where I have the sun, and down here is going to be the Earth. The Earth is down here. How far away is the sun from the Earth? How far away? 1
AU.
AU, 1 astronomical unit, right? And then let's say I see Mercury over to this side. Would that be Eastern or Western?
East.
Eastern elongation, right? I see Mercury over here, and it's making a triangle right here. I see Mercury right here, right? It's actually the greatest eastern elongation. And I know this is a right angle. This is 1 AU. This distance is 1 AU. What's this distance? Well, I don't know. But maybe I want to know, right? Maybe I want to find that out. I know this distance. I know this distance right here. And it turns out that all I need to do is measure this angle. Figure out the angle of greatest eastern elongation. What is the angle, right? That's the question. And then all I have to do is draw a little triangle. I draw a little version of this, and I can directly measure, as long as I make them the same set of angles, right? Then they're going to be similar to each other. So I can measure this, and I can measure this, and I'll be able to figure out what this distance is, okay? Because they're similar triangles. All right, you understand the principle? Okay, so don't draw anything yet. What I want to do is don't draw anything yet, is take a look at this diagram. How do we determine the distance to a planet to the sun? And the answer is, well, we know the distance from the sun to the Earth. We can label that if you want. What's the distance? 1
AU.
AU. Okay, don't put anything else on the paper right now. Okay. All right. So the question is, where is Mercury going to be? It's going to be over here somewhere. And I want to find the place where it's greatest eastern elongation. How many degrees away? Okay. So I'm going to go ahead and jump back to my program, and I'm going to show you how cool Stellarium is. It's a really cool tool. Really cool tool. Okay. So right now, actually, I can't tell. Is it Eastern or Western? I can't tell. Let's go back. What do you say, Eastern or Western right now?
Oh, Eastern.
Eastern, okay. So I've got the right direction. I have to go back. I'm trying to get further and further away from the sun, right? But this thing actually has a really cool tool. Oh, hold on, I can't find it with all this. Can't find it with all this stuff. Okay, I'm gonna go right here. It's called astronomical calculations. What? Check this out.
Ooh.
And This is gonna be crazy. Look at this. You're gonna go over here to PC. I don't know what PC stands for. I do not know. But I already did this ahead of time, so.
Is it
if you take a
planet
look-
calculator?
Yes, it's a planet calculator. Oh, there you go, planet calculator.
Ooh.
Thank you.
That's awesome.
That is awesome, right? So Sun, Mercury, take a look right here. Angular distance, that's not what I want. Shoot. That's not what I want. Something's off. Linear distance. Oh, shoot. It's not supposed to show me that. I don't want that. Hold on a sec. Let me see if when I change the date, it changes. Can you guys see the numbers? I don't know.
A little bit.
Are
Yeah, the numbers changed.
The numbers changed?
Yeah, look, they went from 25 to 16.
Okay, so let's see. Can you see the numbers still? Okay, you guys are going to try to watch this for me. Okay, so we're going to try to see it get bigger. Okay. Is it getting bigger? Getting bigger, right? See the numbers getting bigger, right? Getting bigger, 23, 24, almost, 24, 24, almost 25, 25.
25 now.
25 is actually almost 26. And now it's going back down again, right? So when, do you see that? So
Yeah.
what was the number? About 25, let's say 25 degrees. It's good enough, okay?
Okay.
So we just determined this angle. You make a little note to yourself. The greatest elongation was an angle of 25 degrees. 25 degrees. Okay, so nobody has the right tools. And so I was like, what the heck are we going to do? And then I realized that you all have something kind of cool. You have this thing right here. And that has angles on it.
Oh,
So I'm going to show you what you could do. I don't know if you really have to do this, but you know, you could think about it. But you need a ruler too. So if you don't have a ruler, it's not going to work.
Oh.
But I'm going to show you how I did this. I'm going to go ahead and take a piece of paper and put it right so that the corner, I'm trying to use just whatever I have, right? So I've got one of these astrolabes. I put it right there in the corner. And I use the corner, by the way, that's marked altitude, right? See the altitude? And I want to try to read the inner number here, 0, 10, 20, and I want to go halfway between 20 and 30. You guys follow what I'm trying to do? Okay, so I'm going to lay this right in the square. And so here's my one edge. My one edge is going to start here. This is going to be 0 degrees. And then I'm going to look underneath. I'm going to actually, I can see underneath the paper. It's dark enough. I can see kind of. I can see 20. I think I can, maybe not. Oh yeah, I think that's right. Okay, it was easier the first time I did this. 10, 20. Oh man, I can't read it. Harder than I thought. 30, okay, here's 30, 30. So I'm gonna count. So 1, 2, 3, 4, 5, right about here. And if I'm wrong, it's not a big deal, okay? So what I'm gonna do next is I'm gonna take, oh, I already messed up. I can see I messed up. So let me try again. 20, oh, I can see it right here. This is 25. Here's my number right there, okay? So I got 25. And what I'm gonna do is take a ruler or a straight edge. I don't need this anymore. And I'm gonna go from the corner through that 25 mark. Okay, and all I'm trying to do is just get this 25-degree line. Okay. And then I'm going to just fold it so that I can use this 25-degree line.
Oh.
Okay. And I'll just fold this out of the way, I guess. I don't know. I'm not sure what to do here. I don't know what else to do. I'm just trying different things. I'm making this up as we move along, okay? So what I have is a 25-degree angle. And what I'm going to do is line it up so that the Earth is here. right? The Earth is here, and the 25, I needed to make this a little shorter, sorry. I want to bend this out of the way. Like making a paper airplane or something, okay. That's my 25-degree angle. I want to make it so that the point goes right to the Earth. It goes like that. And then I want to draw a line along here, touching the edge of the paper. So I messed it up a little bit. So let me just use my straight edge again. Now that I got the start, I can go ahead and finish it with this. All right, so I drew this line and now I have a 25-degree angle. Okay, so you can try to do this if you want. Otherwise, just roughly sketch it. I don't know how else I'm not gonna be able to check it very easily. And now our last step. The last step is, if you remember, Mercury is gonna be somewhere on this line, right? But the idea is that the angle between Mercury and the sun is a 90-degree angle. So now I'm just gonna use a piece of paper with the corner, right? And I'm gonna slide the edge of the paper along my line until it just touches the sun, right? So the sun just peeks out, right? So the edge of the paper just touches the sun right here, and the other edge is along the line, right? So this is gonna make the rest of the triangle. Okay, so I was able to complete the triangle, and now I know this is a 90-degree angle. It's not perfect. It would have been better with a protractor, but it's good enough, okay? So would you consider this triangle to be a big triangle or a small triangle?
That's a big one, right?
Well, actually, it's tiny because it's supposed to represent 1 AU, right? There's this giant triangle in space. It's huge, right? It's between the Earth and the sun, and now we know Mercury is here. Mercury is here. And the question is, we want to know how far away is Mercury from the sun? And so what we're going to do is we're going to measure very carefully with a ruler. We're going to measure the distance between the sun and the Earth. Now my ruler, I'm going to use the metric side. I'm going to go from the center of the sun to the center of the Earth. And I'm going to measure the distance. And it looks like I got 11.1 centimeters. Oops, I messed up. No, 11.1, 11.1, okay? And then I'm going to measure this one right here. You guys could write that down if you want. I'm going to measure this carefully. And I'm going to go from the center to center. And I got about 5.1. Okay. So this is my little tiny triangle. I could call this side A, and this side B, and this side C, right? And I want to compare it to the triangle that's out in space, right? So I don't care about A, I want to know about B, right? So the idea is that 1 AU on this picture is represented by a distance of 11.1 centimeters. It's the same thing. So what is this distance going to be, right? And the answer is X. I don't know what that is, but it's going to take up a distance of about 5.1 centimeters. We set up a ratio. You guys follow what we did?
Yeah.
Okay. And so the last thing is, how do I get X by itself? Anybody remember how to do that? There's more than one way.
Isn't one of the ways that you divide like across?
You mean cross multiply? Is that
Yeah,
what you're
that's it.
Okay,
You can't
you
divide
could do that.
fractions.
Okay, so you go like this equals this, right? So X, so we're going to cross multiply. X times 11.1 centimeters equals 1 AU times 5.1 centimeters. Okay, but I want to get X by itself. So how do I get rid of the 11.1?
You divide by 11.1 on both sides?
11.1 centimeters on both sides, right? So what happens to the centimeters? They cancel. And so my answer is going to be, and this cancels, right? My answer is going to be an AU, or astronomical unit. So I do need to get out my calculator right now and do that calculation. Anybody want to try to do that for me? You got 5.1 divided by 11.1. And 5.1 divided by 11.1. You can try to do this, okay? And I got, what'd you guys get?
It's pretty long. It's like
0.46 AU. Now that's not quite right. It turns out it's closer to about 0.39. But the funny thing is Mercury has a very interesting orbit. And it turns out that you need to watch it a few times to get an average. So sometimes it looks a little bit further from the sun, and sometimes it looks a little bit closer to the sun. And so if I did it on an average, I would find out I would get a distance which is closer to 0.39. But you can see it's greater than, but it's pretty close to, nearly the same, nearly 0.39 AU, right? Pretty close. So you get it, you get an idea. How did the ancient people begin to figure out what these distances would be? They did something like this, right? So what we did tonight is we watched Mercury, and we saw that Mercury actually goes through phases, and when it's on one side of the sun or the other, it has one phase or another. But we actually looked at the elongation. Sorry, that's what we did. We did the elongation. We found it had a greatest eastern elongation of about 25 degrees. Okay, so could you do this on your own without me? What do you think?
I could probably, I could attempt it.
All right, well.
I'd have to acquire a ruler first.
Okay, yeah, you have to acquire a ruler. Okay, so I'm debating what I'm going to do, but one of the things would be to try to do it again with Venus. Try to measure the distance to Venus, measure the orbital period of Venus, right? You could do the same thing, and then you could try it and see if it works, and then you could look up the real answer and see if you got close, right? Maybe just one last thing, just to show you guys something interesting. So I mentioned the phases of Mercury and Venus. But let's take a look at Venus this time. Let's just look at Venus for a second. And I can get rid of the extra stuff now. We don't need all that. Let's look at Venus, right? And actually, there's Venus. Okay. So we're going to center Venus. And again, it's a little bit, but where would you say Venus is? To the east or to the west right now?
West.
It's to the west, right? So what would that be? Morning or evening?
Morning.
Morning star. Okay. So actually, I should have gone back to where we are now, right? What's the day today? The 9th. What is Venus? And actually, Venus
is evening now.
Venus right now is eastern elongation, right? So
Yeah.
which means it's what?
Evening.
An evening star, right? And if you zoom in, you can actually see the phase. And what is it? I don't know. It looks like it's about maybe almost the first quarter. What do you think? So
Yeah.
if I advance time, oh, wait a second, I'm wrong. What is it?
It's the other way. That was
It was
third.
the waning
Waxing.
crescent.
It's
Waning.
Yeah, waning.
Okay. So that was about is actually a third quarter then, right? Okay. So it's becoming a smaller crescent, right? And then eventually it's going to become new. And what will it be called when it's new? What's the name? Notice that it's growing, by the way, too. What's it called when it's a new Venus? What's the name for it?
Oh man.
Lined up with the sun. What's it called?
It's the.
What's my function?
It's superior.
Conjunction.
That's right.
Conjunction.
Did you get that song?
Yes, I love Schoolhouse
Conjunction,
Rock.
what's that function? Which one? Inferior or superior? Which one?
superior, right?
Inferior, because it's
Inferior.
between the sun and the earth, right? But
Yeah.
as we watch Venus, right, we're going to see that the crescent will begin to appear. There it is. Look at it go, right? So it's got a nice crescent and it's starting to move away from us, getting smaller and moving away from us. Now it's about a first quarter, right? Getting fuller. So now it's gibbous, waxing gibbous. And at some point it's going to be close to full, right? Okay, and getting pretty close to full, taking a little bit longer, right? Because Venus takes about 2/3 of a year. Now it's pretty full, I would say. So, and if I look right here, I'm going to see Venus is nearly, not quite, not quite lined up with the sun. That's even close. It's got even more time. I guess it does. Okay. Okay, still not full? Huh? Gotta be full by now. Taking a while. Venus is kind of slow.
Oh wait, starting to shrink again. I think.
Oh, now it's okay. Now I can see it start to get dark, right? Okay. So now
Jeez,
now
it
it's
can
a
take
gibbous
its
again.
time.
Yeah. Okay, so you can actually see phases for Venus. It takes a long time, right? It really takes a while. Oh, there it goes. Definitely gibbous. Third quarter. Looks kind of cool. Neat. Okay, it's just taking a long time. Okay. So actually, let's try something. Let's try something real quick. Just take a look right here. Focus on the sun, but still be able to see Venus. Watch, and I'm gonna actually make. Oh, I can't do that. Can I make it a month at a time? That's so big of a change, right? You see Venus? Okay, it's moving. It's moving too much. Okay, I wanted to show you. Okay, it's moving. Whatever. Mercury moves a lot faster, though, right?
Look at it go.
Mercury is like booking around. Okay. So watch Mercury. Do you see how Mercury moves towards the east or towards the west? One way is slow and one way is fast. Can you figure out which way is fast and which way is slow? Mercury is, just watch Mercury because it's going a lot faster. Which way is it slow? When it goes towards the east or when it goes towards the west?
It seems like it's slower on the east.
Going towards the east, right? And think about why that would be. Why would it be that it's slower towards the east?
It's got a skewed elliptical orbit.
Well, actually, that was pretty close. It turns out it's not quite that it's elliptical orbit, it's what we see though. Okay, so if I take a look at the orbit, sorry, let me look down at the paper again. If I look at the orbit, and I think we're pretty much almost done actually for what I'm gonna do tonight. If we draw the sun, and we draw Mercury, and we draw the Earth, okay. When we watch Mercury, we see it, kind of swinging between being eastern and western elongation. When you go from greatest eastern to greatest western elongation, you only have to go this far, right? So it's going in this direction, right? Going in this direction. And when it goes to the east, look at how far it has to go, right? To get over to here again, right? So you see how it has to go almost twice as far. And so when it's moving towards the west, it's very rapid. And then for the east, it's kind of slow to get back over here. And then west is rapid, slow, reset, right? Like that. Okay. So anyways, so we've explained how we see phases for Venus and Mercury. Maybe the last thing, okay, very last thing, is to just show you for sure when I look at another planet further away from the sun that I don't see phases, just to prove that to you. But let's look at Jupiter, which looks awesome. Jupiter, okay, there's Jupiter, and we're gonna center it, okay, and then we'll zoom in. Now this one I'm gonna have to do month by month because it's gonna take too long. It takes
You
12
haven't,
years, right? So what I wanna do is just, oops, what happened?
you have to share the screen.
Oh, I didn't share the screen?
No.
Oh, that's a fail. Okay. Thank you for saying that. Okay. Sure. Okay, now you see it,
There we
right?
go.
Sweet.
Okay, center that. Okay, and now advance. Okay. It was getting too big there. Okay, but I want you to watch month after month. What do you notice? Full or gibbous or crest?
Cool.
It's
Definitely
just
full,
full.
right? Do you see anything at all? I mean, there's maybe a little darkness here somehow, huh?
Yeah, it's
But
not really changing.
Yeah.
It's been about
Not even-
7 years.
Let's see if I jump year by year. It doesn't even.
Look,
Oh, no,
that.
actually that wouldn't. Month by month. It's got to be month by month. Okay. So basically, what phase?
Full.
Oh, I know what it was. Actually,
Whoa.
Whoa. Oh, we can't hear you talking anymore, Sean.
Yeah. I think your audio's off.
Yeah.
is my audio off?
Oh, now
Yeah,
we can
it's
hear
on.
you.
I can hear you now.
Okay, yeah, but all I did is turn it off and turn it back on again, so it's gonna
Ah,
die. Okay, so if you look at Mars, what phase do you see?
it's
Full.
It's
full.
pretty much full, right? Okay. But I just realized this could be one that I could ask you to do. So I don't know if I'm gonna do that. If I do, I'll give you plenty of time to do it. But basically, that's about all I have for tonight. And so I'll give you guys a quiz that'll be based on everything we covered. Mainly, the conjunction, the inferior, superior planets and things like that. And it'll probably be up by tomorrow. Probably I won't get it up before tomorrow, and you'll have a week to do it or so. And then the homework on page 12A, you don't have to finish until next week. Hopefully you look at the real stars and do that. And then I will be trying to come up with an activity because we can't do our outside activity. Maybe I'll give you something else that's kind of cool. But if you didn't notice, that Stellarium program has all kinds of cool features in it. And so if you just think about, spending a little time with it as your work for the lab, that would be like one way to
Cool.
improve your understanding and also learn something kind of cool and do observations. It's virtual.
Oh, the audio stopped again. We can't hear anything.
I know. I can't even see him anymore.
Yeah.
Thank you for coming tonight. Thank
Oh,
you.
thank you.
And have a good night, and we'll see you guys next week. I'll get
All
fresh batteries.
All right. See
Hey,
you next
Sean,
time.
Okay.
See ya.
See you later. Bye.
Hey, Sean, have you seen the pictures of Jupiter that they've posted?
Oh, they're fantastic. They're
Yeah,
beautiful.
they're pretty cool, huh?
They're amazing. That's the Juno mission. Yeah, they're
Yeah,
absolutely
yeah.
amazing.
Yeah,
Definitely.
I thought that was cool.
I
All
love
right,
them.
well, have a good one.
You too, buddy. Bye.
All right, man. Peace.
Bye.
My batteries get low.
Who's that?